This is an important section for understanding really just the math that goes into thermal loading and the body reaching elevated levels of core temperature. Let's start off a review of what we mentioned earlier is that metabolic heat production is a primary driver. So about 75 to 80% of energy released is liberated as heat. So the majority of the work that we put into is not mechanical work as an output, but it's actually heat. So when you train at a high level, you generate a lot of heat. Now, for example, some estimates is that a resting human generates around 100 watts of heat. So that's joules per second. At moderate cycling, moderate intensity, you can see that metabolic heat production going to 400 to 600 watts. Now, elite athletes and at peak intense sprinting have been measured over 1,000, sometimes up to 1,200, 1,400 watts in really, really peak high intensity sprint type exercises. So the body can generate a lot of heat. Now, where this becomes relevant is the thermal balance and heat flux. So heat flux is the net transfer of thermal energy. So this could be going in or out of the body. Now you think about the difference between being a state of hyperthermia versus a state of hypothermia, body trying to warm itself up, body trying to cool itself down. There's a large spectrum of conditions where heat is flowing in and out at different rates of the human body. Now, what we're focused on here is the different variables involved. So there's metabolic heat production, there is mechanical work that's done, and then there are also all the different cooling. So really, you generate all this metabolic heat, some of it goes to work, and then how much can you dissipate by cooling to try and create balance? You want to create heat flux as close to zero to maintain homeostasis. If the heat flux maintains positive in favor of metabolic heat production, that's when you start seeing heat storage, loading, the thermal loading going up, and that leads to elevated core temperature. So you got evaporative, radiative, convective, and conductive heat losses. So positive heat flux means more in than out. Core temperature goes up. Negative heat flux, you're able to cool more than it comes in. That's when you can get into a state of cooling. So these are the variables, the levers that you have to play with. Now, as thermal load accumulates, internal and skin temperatures will rise. Now, in future modules, we're going to go through what are the physiological responses to this. So we're going to see sweat rate is going to increase. Sweat rate is going to increase. So this is that we can help cool ourselves down faster. Skin blood flow is also going to increase. So vasodilation to cool through the different portals on the body, that happens. You're going to see RPE go up. You're going to see CNS drive go down. And then core temperature is going to continue to approach the thresholds where you start to see performance drop off. This is more complicated and more detailed than what's going to be probably necessary, but it's a great little overview here. These are some of the different variables that are involved in that overall equation. So you have personal heat exposure, and this is where we're really focused on metabolic aspects, so the intensity, the duration, the frequency. You're going to look at the overall heat stress. Now, what this is really a combination of the internal heat production and the environmental heat load, and that's going to vary significantly. But what really matters is if we get into the top right here, and this is sort of that flow chart saying, all right, we're in a state of heat stress. Can the human body release enough heat to the environment to maintain equilibrium? So if you say yes, then it's compensable. This means your body can compensate for the heat load that's going on, which means you can stay in your optimal range of performance and keep working. If the answer is no, it's uncompensable. This is when your body cannot keep up and you will hit a limit. You will elevate the temperature and the load will be exceeded. That's possible. And that's when you start to see strain, is when the body can't keep up with it in order to maintain homeostasis. And then eventually you see performance and health decrements happen after that.